Hi, I'm Mohammad Reza Beiruzi. We are proud of ourselves that you watch our videos and we can make a small contribution towards your knowledge improvements. These videos that we have uploaded on our website or on our YouTube channel consist of notes and real case examples from our last projects. Those projects were performed by a team of professionals and experts. Therefore, by watching these videos, you can gain tremendous amount of knowledge and experience by which you can design your process units, your plants with highest safety. You are our only sponsor. So if you enjoyed the video, at the end, hit the like and subscribe so that you can get informed about our latest videos.
Hi everyone, I hope that you are doing well, but in order to test my voice, can you hear me clearly? Just write down in the chat sections yes or no. Okay, I think we can start. And unlike the previous webinar, this webinar will be recorded so that other attendees who cannot attend this webinar will be able later to watch from our website or through our YouTube channel. And right now I have shared my screen, entire screen. Is it visible for you? It was visible for you? Okay, so we can start here. As you know, this webinar is about Flowmeter selection, sizing, and troubleshootings from basic design to a startup. The content of this webinar consists of general procedure, selection pattern, examples, sizing Coriolis flowmeters, vortex flowmeters, orifice flowmeters, piping design considerations, algorithm of calculations, our mistakes and experience, summarizations, vendor list, and in total it's gonna take about 60 minutes or 1 hour to finish this webinar. I hope that this webinar would be a great help to those process engineers who need to enhance their knowledge about flowmeter sizing and selections, or in the process of or are working as application engineers or process engineers in some vendors companies or licensing companies. So I'm gonna jump directly to the main issue here, and in order to avoid any wasting of time. General procedure. General procedure for the project of flowmeter selections consists of 5 steps. Selection of proper type of flowmeter for a specific application, sizing of that flowmeter, installation and piping design considerations, a startup and normal operation activities. In this webinar, we're gonna proceed step by step and see how a flowmeter should be selected, sized, and which installation parameter should be taken into account during detailed engineering. And at the end, we're gonna talk about our experience and mistakes about compensations of these and algorithm of these flow meters during a startup and normal operations. The first step, as I stated, is selection pattern. A piece of advice, not for this webinar, not just for flow meters. If you want to get on top of a field of process engineering or general engineering, try to find some patterns. If you are dealing with material selections, of course there is a patterns. So try to find that pattern and get on top of that subjects. The same happens to flow meters. The same happens to flow meters, sorry. Flowmeter selections also has a patterns. These patterns has been widely used by many licensing and leading engineering companies. I've seen in their documents, and of course in last projects I use these selection patterns. At first I'm gonna name some of these flowmeter types and then review these tables, and at the end of this selection patterns I'm going to provide you with some detailed engineering and detailed examples in order to make you understand fully how to select the best type of flow meters for a specific applications. So here you can see different types of flow meters: venturi type, flow nozzle type, rotometers, turbine types, annular types, pilot tube or annubar types, positive displacement meters, vortex flow meters, ultrasonic flow meters, Coriolis flow meters, magnetic flow meters, and the most common ones, orifice flow meters. But in order to familiarize your mind, your eyes with this kind of, the relationship between flow meter type and applications, different applications, I have created this table for you in these PowerPoints. We're gonna review quickly this table, and later in different example see how these sentences and these sentences in this table means. For gas stations in petrochemical plants, it is typical to use ultrasonic flow meter type. For fuel systems, we can use ultrasonic turbine and vortex flow meters. We use magnetic flow meters for applications in which we are dealing with fluids with high amount of conductivity, which is more than 5 microsiemens per meter. Whereas we use vortex flow meter type for application in which we are dealing with fluids with conductivity less than 5 microsiemens per meter. We use venturi type for low pressure gases, while we use flow nozzle type when we are dealing with high pressure steam services or high erosion is present. And when we have battery limits, when we want to measure the flow rate of the products, the expensive products, we use Coriolis flow meters, mass flow meters such as Coriolis flow meters. And the most common one, orifice types, are used for process units when controlling parameters is a high priority. We just reviewed this table in order to familiarize your eyes with the relationship between flow meter type and applications. Let's see some real example from my last projects to better understand the relationship between flow meter type and applications. Everything has a pattern. So try to find these patterns and get on top of these patterns and become a professional process engineer. Here you can see the gas stations. In every petrochemical plants, we have gas station at the inlet of the plants in order to regulate, filter, and measure the flow rate of the gas inlet to the plant. As you can see from the PowerPoint page, the flowmeter type which is used for this gas station is ultrasonic flowmeters. Based on at least in my country, it is not only just a suggestion or something or advice or something like that one. Now it is a regulations, and we have to abide, we have to follow the such regulations. We are supposed to select ultrasonic flowmeters for gas stations because ultrasonic flowmeters has proved successful when it comes to the measurement of the gases to the inlet of the plant. Then I talked about magnetic flowmeters. I stated that in that table that we use magnetic flowmeters for application in which we are dealing with fluid with high amount of conductivity. One typical example of this application is cooling water systems. I don't know whether you have had experience working in petrochemicals in normal operation or not, but those who have worked in petrochemicals in normal operation periods know that the typical conductivity of cooling water is around 200 microsiemens per meters. It is much more than 5 microsiemens per meter. Therefore, for dirty products, for dirty fluids such as cooling water systems, of course it's not that much dirty compared to clean products, such clean fluids such as the DM waters. They are dirty in comparison with DM waters. We use magnetic flowmeters. As you can see on the page of the PowerPoint, magnetic flowmeters for this cooling water system was used. Not just for cooling water system, we also have oily contaminated waters, partially POC or COC, completely contaminated oily contaminated water, or partially oily contaminated water. They also have a high amount of conductivity, and we use magnetic flowmeters for these applications alongside cooling water systems. Next, we have polishing units. In almost each process plants, including refineries, petrochemicals, we have polishing units because we need to provide the steam generators, the BFW, boiler feed the water, and in order to reach these boiler feed waters, we need to have the polishing units. Of course, here it is not within the scope of this webinar to talk about the function of the polishing units, but just know that we have polishing units, and in polishing units we have demineralized water whose conductivity is less than 5 microsiemens per meter. Therefore, based on experience and typical practices, it is a normal practice to use vortex flowmeters for these applications. Vortex flowmeter is not just used for polishing units. They could be also for some fluids which are clean. For instance, they could be used for fuel systems, because fuel systems should be clean and abide by the aspect of the fire heaters, by the aspect of furnaces. Therefore they should be clean, and because of their status of being clean, we can use vortex flowmeters for fuel systems. Then we talked in that table, we mentioned Venturi type. In this example, those process units or petrochemicals who have fire heaters have inside the package of fire heater there is a ID fan or FD fan, forced fan or induced fans, and the function of these forced fans or the combustion air blower is to blow air to the fire heaters because of the combustion purposes. So the function of this FD fan is to blow air to the fire heaters, and since the pressure of the inlet pressure of the combustion air to the this FD fan is very low, it is really negligible, we are supposed to use Venturi type. Then we talked about high pressure steam services. We said that it is better and it is a normal practice to use to use flow nozzle flow meters. Such one example of this one is steam drums. We have steam drums. This steam drum, the operating temperature of these steam drums is about 400 degrees Celsius, and the operating pressure is about 90 bar gauge. And for such applications, we are supposed to use flow nozzle flow type, flow nozzle flow meter type. And Coriolis flow meters. As I stated, based on that table, we said that when we are dealing with the product measurements, product flow rate measurements, we are supposed to use Coriolis flow meters. Coriolis flow meters are the most expensive one compared to other flow meters, and they possess the highest accuracy. And since the whole purpose of these refineries, these chemical, these process plants, these petrochemicals are the products, and since we want to sell our products with highest with highest profits, we should be very meticulous, very careful with the flow rate of the products, because it is extremely expensive and we want to make more money. And in order to avoid such financial consequences, we have to select the best type of flow meters, which is Coriolis flow meters for these applications. So we select Coriolis flow meters for products. We have other fluids which enters or goes out of the plant at the battery limits. For those fluids which are not categorized at the products, we can use vortex flow meters as well, depending on its status, whether it is clean or not. But it is always better to use Coriolis flow meters even for those fluids which are not products, because you are dealing with money. You have to pay the nearby company from whom you are receiving the fluid the money, regardless of the fact that whether that fluid is product or not product or a fit to your plants. You have to be very accurate at the battery limits because you want to save money. Later we're going to talk about this one, don't worry. Then we have process units, typical process units. Process units where controlling parameter is a high priority. We use orifice flow meters. Orifice flow meters are the most common types. One example of such process units is distillation units. In my last projects, in distillation units, we used for all measurements of flow rates, we used just orifice flow rates. Why? Because we wanted to deal with the control of flow of reflux to the tower or the inlet to the tower. The measurement of that unit was not that much important for us, because the fluids which is considered a reflux, it doesn't matter to me to sell it, because we don't sell it. Therefore, it is not that much matter. The thing that here plays a crucially important role is the controlling parameters. So when we want to select the flow meter whose purpose is controlling parameters, we are supposed to use orifice flow meters. Everything is good? Just give me a reply. Yeah. Okay, thank you. Then let's get back. In order to summarize what we have learned, I've created a kind of a picture here to help you remember this for a long time, not to forget it easily. In petrochemicals or refineries, we have these units. Gas stations, especially for petrochemicals. Gas station, process units, battery limits, cooling water units, polishing units. The gas from the refineries enters the gas station for regulation, measurements and filtrations, then goes the process units. We do some actions on them and produce the products, and at the battery limit we sell our products. So for gas stations, as I said, that we use ultrasonic flow meters. For process units we use orifice flow meters, and for battery limit we use Coriolis flow meters because it has the highest accuracy, and we want to make the highest profit, because we are dealing with the selling our products and it is extremely expensive. We don't want to make any mistake. And we have cooling water units. Inside the process units we have some hot fluids which should be cooled down. I mean, we have some equipment such as heat exchangers, and some of these heat exchangers, the cooling medium is cooling water. And for cooling water units we use magnetic flow meters, because we are dealing with dirty fluids. And unlike the cooling water units, for polishing units we use vortex flow meters, because we are dealing with clean fluid such as DM water. Now the process of selection of proper type of flow meter is finished. Based on this criteria, based on this procedure, you can simply select the best type of flow meter for your applications. Now the next step, based on the general procedure, is the sizing of them. Flowmeter sizing, example methanol, and the software which is going to be used is the software of Emerson Flowmeter Sizings. Of course, it is not a kind of software, it is a website, but when you work with this website of Emerson Flowmeter Sizing, you feel that you are working with a built-in software, and the result, the output of this software, of these websites, is extremely accurate. I really like these websites because I have used this website, the website of the Emerson Flowmeter Sizing, for many applications, and I have been very satisfied with its results. Therefore, I highly recommend you using this, Emerson Flowmeter Sizings. Alongside Emerson Sizing, Flowmeter Sizing, we also have Andres Hauser's sizing applicators. You can go to the internet and later see how you can size your flow meters using that applicator from Andres Hauser. And here I have prepared the websites. We're gonna see their websites and how we can use the websites here. Here we are dealing with special applications, the methanol products. The methanol is going to be sent to the storage tanks. Here we, as I said, since the methanol is the product of our company, we are supposed to use Coriolis mass Coriolis flow meters, because it is really expensive and it is the purpose of our company. It is our products, and we selected Coriolis flow meters during detail engineering. And let's look at the flow rate here. The maximum flow rate is this value. The normal flow rate is about 126 ton per hour. The minimum flow rate is about 42 ton per hour, and maximum flow rate is 150 ton per hour. Here you can see the operating pressure, operating temperature is this value. Operating pressure is 3.5 bar gauge, and here you can see some physical properties of the fluid which should be measured. And the maximum allowable pressure drop should be this value, and this meter is going to be put into a line with the diameter of 6 inches. Here I have taken some picture shot from this website. Let me open. just online. I'm going to show you how to use this applicator. Here you go to the Emerson's website, you select for instance the application for this one is Corellis Flowmeter. I just want to show you, familiarize your eyes with the environment of this website, and later you can use it for your applications. Here, as you can see, as different you should provide the applicator with different inputs. Here it says that the measurement type is flow, the select technology Corellis magnetic or vortex, we select Corellis type, and equipment selections Corellis Flowmeters, all of the elements of this should be included. Application requirements, we do not click anything here. Product family, all sensors should be included. You know, it has different product families, but we select all sensors. And line size here, look at the line size here. It is 6 inches. You can look at the piano ID, it is 6 inches. And then you have to fill in some information about fluid and process variables. Fluid is a liquid. Fluid source, you can select the database or custom. You can simply select the database, and the software is gonna calculate the property of the fluid from its database. So pick fluid from database, it is methanol. Here you can see methanol. And let's have a look at the operating condition. It should be in kilogram per hour. Pay attention to these units. And in bar gauge. And let's enter the values. Line pressure, .5, temperature, just one thing I want to mention is that it is not just every website. You know, as process engineers in past years, I've used many websites for my calculations, and but this is not just every website that I selected for this webinar. It is exactly like a software, and it has created, Emerson has created such website in order to make it user friendly for all you know, engineers to use it. And the ambient temperature is 35, and 35. And the maximum pressure drop should be this value. It goes to its fluid property, it goes the fluid, the data back, and select the properties of the methanol based on the operating temperature and pressure. And we click sizing results. We wait for the results. As you can see here, the Emerson offers you different types of flowmeters here with different characteristics and with different outputs, process outputs. Each flowmeter has a specific pressure drop, tube velocity, and here it says that it could be manufactured with diameter of 6 to 8 inches or 8 to 10 inches or 10 to 14 inches. Since our line size is 6 inches, this one is not suitable for one, or this one, or this one, or this one. Just 6 inches could be selected for this ones. And to make you better understand how to we select just one of these. Yeah, the Emerson software has suggested one option for us. These options from this family of Emersons, with this floor with these inches. Remember that one piece of advice: nowadays or even in the past, when you want to create or produce some data about a new plant, design a new plant, you have to consult some vendors in order to create your piano ideas. If you want to, for instance, design separator for a specific applications, you have to consult Koch-Kilich or Sulzers, because they have, or my sub company, because they have the technology, they have the software. You can use just, don't think in that way that we can use some Excel sheets. You see there are a lot of Excel sheets in LinkedIn or other platforms circulating, and we like them, but they are not practical, they are not realistic. They just give you some understanding of how to size a specific equipment. You have to use a specialized software or consult with a specialized company. When it comes to separation technology, myself, Koch-Kilich, or let's say Sulzer. When it comes to control valves or flow meters, Emerson, Andreas-Hausers, or other flow meters manufacturer. At the end of the sessions, where I'm going to show you the vendor list, you have to consult with them, because they can because when you consult with them, they can exactly say that the sizing of the flow meters, which type, which family, all information could be provided. And that's the reason I show you this Emerson software. So here, for different flow rates, so for this flow meter, based on different flow rates, there are different pressure drops from the minimum to the maximum flow rate. Of course, the pressure drop changes, and here we can see the velocity. Our normal flow rate is this value, 126 tons per hour, and the velocity is 3.6 meter per second. It's a good match, and these flow meters could be used for our application. I'm not saying that it is the finalized one, because if you look at this one, the flow meter is 4 inches, not 6 inches. And by the way, this flow meter was not supplied by the Emerson. It was supplied by other vendors. So it depends on your engineering companies and your licensors, who for instance, with whom they are partnering and who their partner is. It depends on a lot of factors. So the finalized one was 4 inches, but if you want to select a product from Emerson, it suggests that, for instance, 6 inch is good with this product family. Now, and of course, here you can see some diagrams, mass flow accuracy versus the flow rate. Now, I just wanted to take an example to familiarize you with the environment of this applicator. Okay, I'm going to continue. The next example is sizing a vortex flow meter for natural gas, which is used as the fuel system for fire heaters. As you can see here, we have methane as the natural gas, which is used as the fuel for the fire heaters, and here is the vortex flow meters and it is gonna be installed on a line with the diameter of 10 inches, and the finalized sizing of this flow meter is 6 inches. Now let's have a look at its flow rates. The maximum flow rates is 10,000 normal cubic meter per hour. The minimum flow is this value, and the normal flow is 8,400 normal cubic meter per hour. The fluid phase is gas. The operating pressure is 4 bar gauge. The operating temperature is 35 degrees Celsius, and here you can see the physical properties of the fluid. And here, as I said, it's going to be located in 10 pipe in a 10-inch pipe. This time I'm not gonna go to the software, just show you how you can show you the picture shots from the websites. You can select flow vortex type and 10 inches. Just a moment. As you can select custom for a schedule and pipe. It calculates the pipe ID here, and here you can see the fluid state is gas. And if you go to the fluid database, you can select methane, because the natural gas, 95% of the natural gas is methane. And here you can enter the data like this one. And see the results. You know, when you enter the data, and the software, the applicator is gonna calculate the fluid properties by itself, and it provides a number of vortex flow meter families. Here there is this option that you can compare 3 selected vortex flow meters. I selected 4 inches, 6 inches and 8 inches in order to in fact finalize the sizing of my flow meters. This one is the first one to the left side is 4 inches, 6 inches and 8 inches. If you look at these ones, you can see that the pressure drop maximum here is 0.2, here is 0.03 and here is 0.01. Of course, it is obvious to us that the higher the size of the flow meter, the lower the pressure drop. That's clear to us, as we know, as an obvious thing as process engineer. But the thing that is really important and can impact our calculation is the velocity. Look at the normal velocity in flow meters. If we select a flow meter with 4 inches, if you look at this, it is 60 meter per second. That's too much. That's too much, and it is not acceptable. But how about the 6 inches and 8 inches? For 6 inches and 8 inches, it becomes much more relaxed. It is 26 meter per second, and for 8 inches it is 15 meter per second. So if I don't take into account the economical aspect of this ones, of course I select 8 inches because it is more relaxed, and of course in the future it can accommodate more gases. But during project phases, it doesn't happen. It doesn't go according to the relaxations, or let's say it is more safe. No, it doesn't always go in this way. The finalized selected one was 6 inches. Why? Because of the velocity criteria. Both 26 and 15 meter per second are acceptable. Both 6 inches and 8 inches are selected. For instance, we produce methanol. The nearby company in the region produce methanol. We have selected 6 inches, but they might select another company with the same licensor might select 8 inches. It is not wrong because their perspective, their experience is different. Both of them are correct, remember that. But for our company we selected 6 inches. In each step I'm trying to make it more detailed. In first example I familiarize your eyes with the environment. In second example, like this one, I showed you some criteria, how to select the best sizing of Flowmeter. And how about the last example? In the last example I'm gonna play the role of application engineer. Who is application engineer? By the way, application engineer is a person who works and deal with different vendors. Who is a process engineer, works for a licensing company, and is responsible to deal with different vendors. He sits or she sits with a representative from the vendor, check all of the calculations by the vendor, and select the best type of Flowmeter equipment or anything else for that specific applications, because after their selections it's gonna be purchased and installed inside, because this point is extremely serious. So application engineer should be meticulous, should be careful with all of these selections. Here the Flowmeter sizing for process oxygens we have in methanol plants, in air separation units, and it's really one of the most important fluids in petrochemical industries. In methanol plants, the oxygen, after passing the filters, it passes through the flowmeters to be measured and controlled, and after that it goes through the valve and goes to the reactor to provide some reactions with the natural gas. Again we use Emerson software Flowmeter sizing. Now let's have a look at the Flowmeter, at the properties and operating condition of the fluid. The maximum flow is 78,000 normal cubic meter per hour. The minimum flow is 21,000 normal cubic meter per hour, and normal flow 65,000 normal cubic meter per hour. It is the operating pressure is 40 bar gauge. It is of course gas, we know that. The temperature is 35 degrees Celsius. Here you can find the physical property of the process oxygen, and it's gonna be sized for 10-inch pipe. Here again I'm gonna use the website. Now, as I stated, my role is application engineer. I am talking to a representative from the Emerson company. Everything is good so far? Okay. Thank you. So right now I play the role of application engineer, and I'm talking to the representative of Emerson company. I say that I need the Flowmeter for my process oxygen application. I know that I have selected by my company, not Emerson, that the most suitable one is orifice type. So I select DP Flowmeters and go to the Flowmeters, because I want to finalize the whole assembly, not primary elements. Just Flowmeters is instrumentation connections, everything, mechanical connections, everything. I'm gonna finalize everything here. So I select Flowmeter, not just the mechanical part, all parts. Sizing name, EIPD, service process oxygen, project name methanol, process piping. The unit of measurements is inch, pipe cross section circular, we know that, and custom pipe ID is standards. Pipe material for oxygen pipes, it is a practice to use a stainless steel 360 or mono as the material for the pipe of process oxygens. So both of them are corrected. Here you can see we have carbon steel, stainless steel, duplex, and chrome moly on and alloys special, but I can't see any monel here. And in order to stay on the safe side, I select a stainless steel because I've seen that other companies use a stainless steel instead of monel with this grade. Nominal pipe size, as I said, the flow meter is gonna be sized for it, is gonna be put into a 10-inch pipe. Pipe schedule, when the nominal pipe size is 10 inches, the pipe schedule is normally a standard. When we have the pipe size of 10 inches, 8 inches, we select a STD or a standard as the schedule of this one. You should know this fact as process engineer when it comes to design of petrochemical and piping plant, and when they ask for process engineering department consultation. You should know at least something about this one, not to be a specialized, but some information about it is good. Flow direction, horizontal, don't change anything here. Then we select next, and we select fluid type gas. Gas type we select database. Fluid database we select oxygens, and don't change anything here. Then if we want to talk about, because oxygen is really abrasive, it can cause corrosion in the future. For now we do not clean anything here, but when it comes to the detailed one, to the last and finalized ones with the Emerson company, we talk about this one with their representative, whether to click this one or not. But now, for now, we do not select anything here because we want to receive the whole family which are suitable for these applications. Then we go to the process variables, process operating. This process operating, you can easily have this data and provide the applicator this process condition, operating conditions such as flow rates, that has pressure, temperatures, and what it is required here. Then you go to next type, primary elements. By the way, you see some options. Let's say it here. From now on, you see some options, and which are the first time you see them, you observe them. Here my role is not to explain all of them because it is out of the scope of this webinar, because it's going to take a long time. But don't worry about these ones, because after these webinars we at EIEPD are going to release 3 comprehensive videos. Maybe those videos take 2 to 3 hours, I don't know. 3 comprehensive videos for different applications, and all of these options are going to be explained. Why selecting this one or this one or this one? Right now my purpose is to familiarize your eyes, familiarize your mind with this application, with these elements in orifice flow meters. So we have different orifice plates, compact orifice plates, or let's say annular primary, conditioning orifice plate. We simply select this one. Why? In my videos you're gonna find out why I selected this one. Just familiarize yourself with these options. And we select next, go to the primary elements detail. We select this value, this material, as I stated. Bore configurations, we have different bore configurations: concentric, eccentric, segmental, restrictions. All of them are going to be discussed in our videos. Don't worry about these ones. For now, select concentric bores, which is more common than others. Tap type, we have different corner tapping, this type of tapping, flange tapping, and these tappings. The most common ones is flange tapping. And orifice, flange, and fitting type, since the And now we should select the class of the temperature and pressure rating of the pipe. If you look at this piano ID, here it is 600. The class of the pipe is 600, so we simply select this one. And by the way, I think it is stated in the data sheet here. Here the class of the pipe is 600. Then calculation standards, we have different calculation standards. ISO 5167, ASME and AGA. The most common one is this one, at least for last projects. And here you can solve for bore size. Preferred DP is this value, and everything is set. It provides you select the best fit for your application. You can see here we select next, manifold style, conventional, and communication protocol. It has different communication protocol like Modbus, Profibus, and Foundation Field Bus, or let's say HART. Since it is gonna be designed for EST systems, because it's one of the trips, one of the causes of our trips is oxygen systems. We're gonna select HART one, and the of course the flow calculations, we should consider compensated mass volumetric energy flow. We're gonna talk about this ones in next section. And here you can see measurement type, process temperatures. We're going to talk about this once because it's one of our mistakes that I made during the last projects. And then we're going to select, and it talks about warranty and displays LCD. Next, and provides you with two options, and here you can configure it, or let's say generate reports and see what which one is suitable for your applications. So it was the procedure that application engineer takes during the detail and the last step during the finalization of the product. So in first example, I talked about I familiarized you with the environment of this applicator. In second example, I tried to finalize the sizing of this ones for sizing of the flow meters, how we can use this environment, this applicator, in order to size the flow meters. And in the last example, I tried to play the role of the application engineer. And by the way, thank you. They are more than this what I explained so far, but in order to watch this kind of videos in a comprehensive manner, stay tuned. And because I think in next month we're gonna release 3 videos, and you see the exact procedure as application or detail engineering of these flow meters. And the last part, which is extremely important here, of course this is not the last part, one to last part: installation considerations, piping design considerations. In piano IDs, some of these flow meters require some piping design considerations. For instance, if you want to install a magnetic flow meter for a specific applications, the flow meter could not be installed at the pumping sites. It could not be installed at the discharge of this pumping site. It should be installed at the inlet of this, for instance. Or for the long pipeline, control valve is usually installed at the downstream flow meters. You can see these ones. This figure should be selected. Or other design consideration for magnetic flow meters. Or For magnetic flow meters, we have also a term, not just for magnetic flow meters, but also for vortex flow meters. We have a term which is installation run. What is installation run? It means that the installation run means the distance between the downstream or upstream equipment, between that equipment and that flow meter, in order to avoid any velocity disturbance, in order to avoid any turbulent situations. There should be a distance between the equipment and the downstream flow meter, or equipment or upstream flow meters. What is this distance exactly? There is a table for magnetic flow meters. For instance, for downstream of pump, for instance, if the magnetic flow meter is going to be installed at the downstream of the pump, the distance between the pump and the flow meter is 30 times the diameter of the pipe, and the distance between flow meter and the downstream equipment should be 10 times the diameter. The same happens for vortex flow meters with different distances. If you want to, for instance, install these vortex flow meters at the near the flow meter, near a control valve, this consideration should be taken into account. For different application later, we can watch, you can read, study these PowerPoint pages and get on top of this ones. For mass flow meters, there is no need to consider for these applications, for these vendors, there was no need to consider any distant run between the last equipment and the nearby equipment and these flow meters. But there are some important issues here, we can later read it. And the last step is pre-commissioning and startup. We have selected the best type for our application. We have sized the flow meter in a good way. We have installed the flow meter in the site with all of these piping considerations in a good way. But unfortunately, one mistake can destroy everything, can bring about all of these financial consequences. And what is this? Compensation. And what is this? The meaning of this compensation. This flow meter, as you can see here, let me go to the previous example to show you what I mean. You see, sizing flow, sizing pressure, sizing temperature, sizing viscosity, sizing density. What does it mean? This means that this flow meter is sized for that operating temperature, for that operating pressure. For instance, I have designed the orifice flow meter for that process oxygens for the pressure of 40 bar gauge and temperature of 35 degrees Celsius. But because of some abnormality, I don't know the reasons, don't like to talk about the reasons, the pressure goes to 38 bar gauge and the temperature goes to 40 degrees Celsius. Now the flow shown by this flow meter is not real, because this flow meter was designed for that operating temperature and that operating pressure. So here we create a box in FCS system. It's a software box, a calculator, put a calculator in the FCS, and it's a kind of logic, and create this kind of algorithm based on the type of flow meter. If it is vortex flow meters, I use this equation, and if it is flow meters other than vortex type, I use a square type, a square root extraction of flow signal with the following algorithm. So here I have flow, raw flow from the flow meters. Remember that it is raw flow, not finalized, with a specific pressure, actual pressure and actual temperature. And remember, it is in cubic meter per hour. Now I have to convert it to normal cubic meter per hour. That's a simple rule that we learned during our university, and it is not related to compensation or something like that one. At first, by a simple conversion, we turn the cubic meter to normal cubic meter. Then after this one, here compensation plays an important role. It says if you see TD and PD here, let me zoom in. You see PD and TD here, that's the operating temperature and operating pressure that the flow meter was designed for. If the actual pressure and actual temperature is the same as actual pressure and temperature if the actual pressure is the same as design pressure and the actual temperature is the same as design temperature, they're gonna cancel each other and all of these are gonna be 1. And this is not important. We do not in real life, in real practice, we do not calculate molecular weight. This is just a theoretical one. We just consider, in our calculation, we just consider P and temperature. So it becomes 1 and this one equals this one. There is no compensation needed. But sometimes the actual pressure and actual temperature deviate from the design temperature, from the operating temperature and operating pressure the flow meter was sized for. 2 stories here, 2 examples here, and I'm gonna finish the webinar. Exactly, I can remember that it was a kind of situation that the instrumentation department wanted to check, wanted to change some of these temperatures based on the data sheet on the temperature on the application. For instance, sorry. So as I was explaining, and sorry to ask, you could see my PowerPoint pages, right? Give me the answer, please. My PowerPoint. Not now. Oh, okay. So here is one mistake by instrumentation department. In datasheet of the flow meter, it is stated that, for instance, we have 2 temperatures: sizing temperature and design temperatures, or sizing pressure and design pressure. In this context, when we talk about sizing temperature or sizing pressure, it doesn't mean it is not related to mechanical temperature or pressure at which the pipe is gonna blow out, is gonna explode. It is not, I don't mean that one. Unfortunately, the instrumentation department, when wanted to enter this TD and PD, they thought that in their mind, they thought that TD or PD here means design temperature, mechanical design temperature, or mechanical design pressure. But later, I'm not going to say this one that I made these corrections. No. I don't like to say how good I am. No, it is not a matter of this one. I found it and I want to tell the story to make you better experience, not to make this mistake. And they said, and I told them, look, this is if you look at the content from the start to the last page of the documents, you can understand that this TD or PD means sizing temperature, sizing pressure, not mechanical design or mechanical design pressure or mechanical design temperature at which the pipe is gonna explode. So first mistake. Second mistake, we receive our plant air. Sometimes we need plant air for cooling down of some equipment or for any kind of reasons. We receive the plant air from the nearby company, but at the startup, the value indicated by our flow meter was not the same as the value indicated by their flow meters, and their flow meters was Coriolis type, our flow meters was vortex type, because as I stated, we can, in battery limit, we can use for fluids, we can use Coriolis or vortex type, and since the plant air is clean, we can use vortex type. But we knew that since they have Coriolis flow meters, they claim that their value is more accurate because they possess Coriolis flow meters. So they made a visit to our site, and we checked everything, and literally I was walking with my colleagues inside, and suddenly something crossed my mind. I whispered in my colleague's ear and said that, you see, I think the problem is that the conversion from cubic meter to normal cubic meter is not made. And he said, don't say anything about this one, we're gonna check it and don't tell anyone. Maybe that's not the reasons, so don't put pressure on us. And we unfortunately we checked it, and that was the reason for this the disagreement between our company and the company that provided us with this fluid. So here, if you look at the PowerPoint, paying attention during a startup and commissioning activities, paying attention to this algorithm is extremely important. This period is called function test. A process engineer, an experienced process engineer, is responsible for checking all of these ones, all of these calculations for each process and control loops for each flow meters. They should check it. It's a long and it requires a long period of time, but it should be checked. Unfortunately, for that flow meters, the instrumentation engineer forgot to put this block, this calculation block, into the calculation of that flow meters. Later we put it with this one. They had the compensation, but unfortunately didn't have this ones. We'll put it here. We created in that calculation block, and the flow shown here, which is in normal cubic meter per hour, was the same as flow rate for that company, which had Coriolis flow meters. And by the way, I'm extremely brave to express my mistakes and my experience, because I don't like other flow process engineers to make these mistakes. And the last part here is, you can see some vendor list here. For instance, for mass flow rate, for Coriolis type, ultrasonic flow meters, the whole version of this one, the complete version of this one, is gonna be shared on LinkedIn, not just for flow meters, for all types of flow meters, for all types of equipment, such as heat exchangers, such as control valves from different manufacturers. I think it is really great help for all of process engineers. One thing that I have discovered in past years is that if you know which company, it is also a knowledge in my perspective, that when you know which company produces which kind of product or which kind of equipment as a process engineer, because later, at least one side of this one, you can go to their company's website and see their catalogs and talk to them, communicate with them, improve your knowledge. So that's the reason why I always in my webinar place attention to this vendor list, because I want to familiarize you with these suppliers of that specific equipment. I think that's the end of our sessions, but before going and finishing the session, I just want to make a review to our website. You can go to the EIPD website here, and as you can see here, it has different sections. Here in video section, you can watch videos for different equipments. They are extremely comprehensive for pressure vessels, for chemicals, for interlock, for process safeties. And you can see here the programs. Each month we provide you with special webinars, and from graduation to industry program it is not has been introduced. And in next week we're gonna release our magazine, our experience magazine, different standards, the mistakes, the experience I have with different standards and softwares, the mistake I have made in the past. And here you can see go to cases and downloads. Here we're gonna make it major changes to cases and downloads in the future. You're gonna be familiar with our experience and our mistakes. Anyway, that's the end of our session, and I hope that you have enjoyed every moment of this webinar. I hope that this webinar has helped you to improve and enhance your knowledge about Flowmeters, a field of processing, an important field of process engineering. And don't worry about this. Sometimes I stated that I ignored some of these elements, some of these materials, because as I stated, I'm going to release much more comprehensive videos about Flowmeters, sizing, selections, and from beginning to the end for different applications. And you're going to watch, and by watching them you can easily get on top of those Flowmeters for different applications. And like always, I wish you a bright future and enjoy your life. That's the end of our webinar for today.